All right. Can you hear me? Okay, cool. All right, I'm going to get started. So welcome to my talk, leveraging the gameplay ability system. A quick intro into what the gameplay ability system is. It's a plugin within Unreal Engine framework. It's not just for abilities, you can use it for a lot of different things, and it's also built to handle networking. So this talk, I'm going to cover the basics of the system, but I'm also going to show usage that isn't the standard way of using the ability system, and kind of show how we used it in our project. I won't be covering a lot of stuff such as that list. So I'll quickly cover my background, and then I'll just go over the core elements of the system. And then if you prefer using blueprints, I'll show you what you can and can't do. And then show basic usage of it, some conditional scenarios, a modular event system, and then just some quick debugging tips. This is my first talk, so bear with me if I lose my train of thought. So I've always used Unreal Engine since uni. So all my jobs, I've done that. Main one being at Mighty Eyes, where we developed Wanderer: The Fragments of Fate. I was the systems and gameplay lead. And then I also a personal project with a team, Mythos Party, which is an online arena brawler. Also my own engine that I tinkered with just in my free time. So Mythos Party, online brawler, has abilities, some weapons, skins, various modes. Really a perfect use case of the ability system, because you have standard slot abilities, standard casting. So it would have been great to use it with that, except we didn't. And we were in a call with Chris Murphy, and he asked if we were using it. We said no. He said, why not? And we didn't actually know about it. And unfortunately, I was at my third refactor of our own ability system, did not feel like changing it again. But the project I did use the ability system in is Wanderer: The Fragments of Fate at Mighty Eyes. So that's a time travel adventure puzzle platformer VR game. What a mouthful, but it has a lot of interactables and kind of intertwining elements with the narrative, with the levels, the gameplay, various NPCs. So it's quite complex for all the things that need to conditionally check and react accordingly. And doing that kind of manually is obviously risk and not as robust. So what is the gameplay ability system? I stole this from the docs. I will be linking the slides at the end, so if I go too fast or if you miss anything, you can just grab the link and look at it yourself after. But the system is basically these 7 elements. You put the word gameplay in front of it, and that's what it's called in the engine. This is the order which it's prioritized, so it's the order of which I'm focusing on, so I won't be focusing on attributes, for example. Gameplay ability system is often shortened to GAS or GAS, which is what I'll be using. So the first main thing is gameplay tags. These are not limited to the rest of the system, so these can be used independently, and they're great. You should definitely use them if you're not. They're essentially the best combination of enums and strings. You essentially have the pre-filtered drop-downs from an enum, but without the user error of having to type in a string every time. And they have an additional benefit of having parent-child hierarchy, so you can do it based on groups. The ability system component is kind of like the core of the system, so everything requires this component and goes through this component. It's actually quite simple, but it's just that kind of core that connects it all together. And the other main thing is it stores the current tags of an actor. Gameplay events are essentially single fire. Send them off. They can be used to trigger abilities or for effects, cues, but also just agnostic events that you can use just whenever you want without any of the other stuff. Obviously, it has to have this component to function. Gameplay effects are essentially kind of like to apply stats to things. You can manage the lifetime of this by either infinite duration, so you can remove it when you want, or instant, so it just applies the attributes immediately, or set duration where it will automatically remove. The good thing with this is it will remove the tags as soon as the gameplay effect is removed, so you don't have to manage that yourself. And these can handle stacking. These are a lot more valuable when using modifiers with attributes. I won't be covering that as much, but that's where their strength really comes in. Gameplay abilities, so they are mostly used for the flow of something, the latent action flow. They're the functional aspect of the ability or the system, not the aesthetic. And they also can handle inputs and set up to work with multiplayer. That's the core of the system, is it's been set up to handle multiplayer as per a standard, MOBA game, for example. So a lot of that's out the box already. And the activation of it can be determined based on conditions, which means that you don't have to conditionally check every time you want to apply the ability. Gameplay cues are the visual of it, the effect or ability. Confusing name is you have the effects, but they are not. They're cues, which are the visual side. They separate the logic from the visuals, so this is something that's less important for a client on the network, whereas obviously the ability is the core that needs to happen. So these are kind of things that can drop off, but they handle all the visuals, such as sounds and visual effects. And these are always triggered they can be triggered manually, but they are often triggered by the effects or abilities themselves. And then attributes, I'll briefly mention them, are kind of just any values which can be limited in range, again, booleans, floats, and essentially each ability actor can have these attributes, and then using the gameplay effects, you can essentially stack, modify, and kind of determine how you want to apply attributes. So good examples there is like if you have damage, but you want to have like armor and piercing, how you handle those combinations of those. But I won't really cover those much more than that. So just to cover the blueprint side, so if you're not as comfortable with C++, can I get a show of hands who knows C++ and Unreal? Okay, that's good, all right. So getting started, it is a plugin you have to enable. Gameplay tags are default, but the ability is not. So you enable that in the engine. Right off the bat, the ability actor, essentially it requires the component, but it's not fully composite, so you do need to implement interfaces. These interfaces are not blueprint exposed, so it does mean that you have to implement them at the C++ level, which is a limitation. But you can use a plugin I've created that I will link later that shows that. You can see here the example of the interfaces being implemented. It's essentially just those two functions to get the component and get the tags. And just, there it is, just getting the tags. It's very simple. So because it's so simple, I thought there would be plugins that exist that already have this. Couldn't really find any. I was quite surprised. So this is my plugin that I've linked to that site. I'll link that link at the end. But it essentially just has an actor that has this stuff already for you. You will have to compile it if you want to get that, though. I haven't extended stuff like attributes, so it's kind of just on the stuff on a need-as-I-need-it basis. So there are some other blueprint limitations. So there's various functions that aren't exposed by default, such as the set gameplay tag count. I do expect this is on purpose because it essentially means you're going outside of the design of the system to kind of modify the tags. But for what we're using it for, which is not standard use, it kind of gives you a bit more control and a way to leverage it a bit more. So I've exposed various stuff in my plugin for this, just for ease of use. These are basic event bindings and also just direct tag modification. So directly setting the tags or triggering it based on a boolean. But these are stuff that do kind of exist. It's the events in a latent action form. So you can still do this, but they kind of means you're limited to like linking it up on begin play, and then it's not as easy to have a bunch of tags and it gets a bit messy. So I'll do like the binding form a bit better. And also means you don't have to have ginormous event graph. So I will now cover how to actually use this stuff. I was supposed to earlier. Could I get a show of hands who's used the GAS, the gameplay ability system? Okay, that's one. All right. Okay, cool. So basic stuff is the tags. So you can modify tags, and the best part of it is agnostic, so you don't have to know the active type. It just goes through the ability system via the interface. So you can directly add and remove tags. You can also directly set the count, as I mentioned earlier. This is essentially treating it like a Boolean. The issue with this is obviously you're directly modifying the tag, which means that if two things are trying to modify the tag, you have this issue where none of them has control and you can't rely on the code. So if you are using this direct setting, it should be only one actor that kind of controls the state and manages that lifecycle. It's essentially like treating it as an internal Boolean, except making it queryable outside of the actor without having to know the type. So you can still use the gameplay systems to query the tag without having to cast to it and know the exact type, which means it ties into all the other elements quite nicely. You can also directly just query with blueprints, whether it has a tag by the interface or the tag count by getting the component. Again, this is good because you don't have to know the class type, so it means that you can very easily query anything and not have to do casting or reference. There's also the tag query, which is very helpful if you're doing your own blueprints or systems that you want to better set up kind of rules for what tags you want. They're good because they can handle complex requirements because they use expressions. So you can build out, as you can see there, based on expressions, all expressions, and then none of these tags, all of these tags. The main limitation with this is it doesn't handle tag count. So it's only linked to if it has the tag or not. And you can't extend these. It's very baked into the engine. So you'd have to make your own system to be able to have these combined with this behavior. But as far as using these, it's quite easy. You just use the interface to get the tags and then use that function, does it match? If you want to know when it matches or when it doesn't match anymore without having to constantly bind events that every single tag could use, they have a default latent action for this, which will just tell you based on which trigger condition you pick. By default, this will trigger every time. It fulfills that, but if you want it to only trigger once, you can tick only trigger once. And if you don't want to, let's say you want to do a when it's no longer met, you can do when false. It doesn't have a when both, so you can't see the changing states. You can just have two other nodes and then check when it switches between them. You can also use this kind of internally for logic. So essentially, easily again, having things apply as tags externally, but you don't have to know about it. All you have to do is listen to those events on the actor, and then based on the change, you can then redetermine your state and apply any change that should happen. So it's an example of just binding to those tag events and then based on the new state, changing what the actor should be doing. So using gameplay effects to manage the tags is again a bit safer. It means that you're not directly managing those call sites, and it means that you can very easily query what the state of this effect is on an actor, and by default it's a lot more exposed by like debugging logs and visuals to know what are currently applied. Again, the benefit of this is that when you remove the gameplay effect, it'll remove the tags for you, and it's a lot more, again, queryable. To do this, if you want to better control the lifecycle of that gameplay effect, you would then set it to infinite, and then you would remove it when you want to be gone, which is slides later. So gameplay queues, essentially there's just a nice little handy editor tool where you can see which queues are linked to what tags. The queues are not directly referenced, they're just linked via these tags as IDs. So you can see which ones you have linked. If you want to link one, you click add new, and it will automatically set the tag on the queue actor. Actually, don't cover it here, but essentially queues are mostly actors, but you can have objects only. But the benefit of an actor is you can have like multiple components that you can do stuff on, like timelines and visual effects and stuff. These queues are auto-triggered, again, based on that tag from the gameplay effects. So you just give it the gameplay effects, the tags for the queues you want to trigger, and the system will automatically activate those linked to the same life cycle by default. For example, if you had an instant effect and you have a queue, obviously for that queue, you don't want it to immediately go away, so that would be not linked by lifetime. For gameplay abilities, they can be triggered automatically as well, again via either gameplay events, but you can also do on a tag added. This will activate an ability that's already applied to an actor. You can also manually trigger these via blueprints or C++. So there's also just a helpful one to just give it and then immediately activate it. But by default, you can give it and then separately try and activate it later, either by a tag ID or by the class itself. And then later you can clear it. It will give you a handle when you give the ability, so you can use that to clear it if you need to. Obviously, ability is quite similar to MOBAs, so they have the quite standard system where you have IDs for your abilities, so you can bind them. So essentially you have the kind of however many slots. You bind an ability to that slot, and the input is just intrinsically linked to it, such as Q is your first ability in a MOBA, and it will just trigger that. So when you swap out the abilities, the input doesn't have to rebound to anything. And then also like standard kind of MOBA style, you can start activating your ability, but then decide to confirm or cancel. This is very similar to when you have a AoE or something that has a visual, but you then decide where you want to cast it. So by default, the system has this where you can confirm and cancel, again, binding those actions, and that will then be usable within the ability flow itself. There is also this kind of more advanced version we did for our game, which was instead of being by these specific integer IDs, you can actually just do it by tags. We can have as many as we like based on a tag ID. We can again swap those out, rebind them, but they're linked to a certain action using enhanced input. And you can also then have, we had a function you could override in the ability when this input is pressed. So I'm going to cover some kind of basic gameplay scenarios to show kind of this usage, which then leads on to kind of how we used it at Wanderer. So for the first example, single event, one trigger, one action. So trigger being the lever, action being a door opening. So if we weren't using a gas, we would just simply cast to the actor by a exposed variable, and then just set the function directly. So obviously this means we have to know the actor, call a direct function. It's therefore linked. Alternatively, you could use an interface, but obviously it's limited to what the interface can do. The alternative is using gas, which is where we would point to a generic actor, so no class, and then we can just send the event. Again, that is agnostic, and that actor can just listen to any event it receives based on a tag and act accordingly. This then means that any other actor can trigger the same behavior without even knowing the actor type. That also means that, let's say you have an actor pointing to multiple actors that do different things. You don't have to know all different types. You don't have to have a base class. You can just switch which one you're pointing to, and it responds based on what event you send it. You can also pass a payload for the information through this event, which is how you'd give additional information if you need it. You often don't need it, but it means that you can actually give it, I don't show it there, but one of the things in the payload is just an object. So you can just make your own object with your own data, so you can essentially give it anything you need. Another basic example of where you'd use an event is a trigger box. We enter a trigger box, fire an event. Again, any single fire stuff this is very helpful for. But obviously the key is it's not a switch back and forth, it's a single fire. That's where we can use tags. So first, better kind of leverage tags. On our lever, we actually want it to kind of change its own state with tags, so we can then query it later. So we can enable a gameplay tag, but because our lever has two states on and off, it's not single fire, we actually then want to set the tag instead based on the current lever state. We can then use this on the lever as a way to drive it sending out the event based on its own tag change. This may seem like a bit of a weird workaround, but it's actually very beneficial, and we found it very valuable when we were developing Wanderer, because what it means is, let's say the triggering of that tag is broken. We actually have commands that we can then switch directly on an actor for the tag by looking at it, and it means that if the triggering action is broken, you can still debug the action, and more importantly, if it breaks narrative and you can't progress, it means you can continue testing if you're stuck with your QA, for example. But then the main thing is, obviously we've got that tag change. So like before, we want to send it to the generic actor. This time, instead of sending an event, we're going to enable and disable the tag. That means, again, we don't have to know the actor, but the actor listening can then switch its state. So in this case, the door be open or closed based on that tag change. Now, obviously, using the enable and disable, as mentioned earlier, it means that it basically has that single state, but you can't essentially stack it. So if you want to have multiple things kind of interact, you're kind of limiting that single link. So to solve that, we then switch to using the add and remove on the tags. Now again, that means you have to make sure that your call site where you're doing this is safe, so it won't double trigger. If it does, and you add two tags, and you remove one, you don't know that you've only got one link to it, which again is where gameplay effects is a lot more valuable in this sense. But what that means is, for this example, we could have two levers, and then if we want to wait for it to have 2 levers switched on. The door can then listen to when it has 2 of the tags and then change its state. So you can see on the second image, we're checking the tag count instead of just assuming a direct link. So this can be seen in this one, which is where we have 2 by default with the first logic, when it's just checking if it has more than 0. So as soon as it has 1 tag, it'll open the door. The second one doesn't do anything, but obviously we turn the other one off, it will keep that state. But if we want it to instead, say require 2, we can then switch 1. It's like, oh, it hasn't got enough. Now it's got 2, open. So as I mentioned before, using gameplay effects is kind of a safer way of managing these tags. So you can essentially apply them directly based on the class. And you can also give it additional context. This context should always be the instigator, but where's the target will be which actor you want it to apply to. You can then store this handle that it gives you to then remove it directly, so you know it's exactly that version of it. You can also remove based on a class if you don't want to keep that pointer. And you can have an additional filter from the instigator. If you give it no instigator, it will just remove however many stacks you want to remove based on that class it finds. -1 means all of them. If you give it 1, it will remove 1. But if you only want to remove the gameplay effect from this actor you're doing it from, it means you can give it that ability system component, and it will then limit the scope of what it can remove, so it can manage its own gameplay effects. This obviously won't work if you have the actor giving multiple gameplay effects to the same target from the same source. So it's a very specific case, but if you have that case, it means you then have to manage each of those individually, at which point then you want to use the handle strategy. So you can see there's handle, you can get the current stack applied if you want to query that, or active effects applied, but it means that you can then use this to remove it directly, so you know exactly removing that specific handle. You can also query the count of a gameplay effect and check if 0, so there's many ways of kind of querying this. By default, the gameplay effects have stacking, so you can limit how many they get applied. So by source is their instigator, the original actor. So you could say this actor can only apply 3 on the gameplay effect. You can also limit it by target, which is the target of the gameplay effect, so where it's being applied to. If you give it by target and 1, it will only let you apply 1 gameplay effect to this actor at all, and then it will not apply anymore. And you can also determine how you want to kind of clear and reset and how it handles those stacks. So let's say currently we don't like it when I can open the lever, turn the lever down, but then I don't see the door open. Not very dramatic, right? I'm looking away. So let's say we want this instead, where we flick down the lever, but only when we look at it, it opens. Doesn't make much sense logically, but for the example, let's assume we want that for the dramatic effect. So we firstly need to determine when you're looking at the door. So for now, a simple site volume. And it will have, again, it's kind of similar logic where it has basic target and actor tags to add, and it also points to that door. This means that we can then, on the door itself, listen to 2 tags. So we have the visible tag and activated tag. So it only means when both are true, it will then activate its state. Because we are using this the tag query, we obviously then have to use this latent event to capture when it changes. Now, initially, this will, as it's triggered once, will only be the first time that you've triggered the lever down and looked at it. It will then open. But if you want it to handle when you look away or close the lever, we would then want to handle both the enable and disable state of the query, which is when we have not trigger once and then both states. And now, obviously, this means that if you look away, it's going to close, which is strange, but again, ignore it for our case. So let's say we have 2 doors, and we want a single site volume to control these both. In that case, it means that both the lever and the site volume need to interact with multiple actors, whereas previously they targeted 1. So an easy way to do this is have an array of those actors and use a gameplay effect we want to apply to it. To make this a bit more usable, extensible, we can have it that each actor can apply a different gameplay effect. So this lever could do a lot more things without them having to know about it. And then we can kind of flip this on its head. Instead of trying to directly apply external tags to an actor that then wants to know the state of things, we can actually have the door instead query other things. What this means is suddenly the site volume and the lever don't have to care about anything else. They just control their own tag state. And then using this query, we can have the door target as many actors we want with whatever query states we want, and it will just listen to those. And then as soon as that's ready, it will then toggle its state. So example of this, we have to then check based on all these actors if they fulfill the criteria. And then we can use this in a latent flow. Note that using latent events like this is quite strange with a for each loop. It's not standard practice. I wouldn't use it, but it does work. So use it at your own risk. I would usually use event binding instead to kind of manage this a bit more safely. But this does work. So it means that we can listen to all those actors, and based on when their query state changes to being true or false, we can then refresh the state of the door to match that. And so this looks like that, where they're both open. And if we look away, they will close. So let's say we want the visible event to kind of be a once-off fire, because we don't care about the visibility after you've already looked at it, once it's opened. We can then switch the visibility to be an event instead. And we can also give additional information via the payload to give the tag context of this. That means then on our door we have to listen to an event along with tag criteria. So we just add that as another field. And then we listen to those events again with the latent action. And for now, we're going to just keep basically a list of all the events we've received, and we can check that against if they've all been fulfilled. Now, this kind of gets a bit messy because then you're doing all this checking of the kind of arrays, and you'll constantly have to recheck based on this when the visibility is triggered. Then you want to listen to the tags of the lever, and then once the lever is down, then you want to open the door. It gets really messy. But it does work. It's just not really extensible and starts becoming a lot more to manage. But you can see there, that's one, the right side's doing it, whereas the left one isn't. So that's kind of where we, at Wanderer, we kind of switched to kind of a bit more of a less limiting structure. So we made what we called modular events. So these are kind of a combination of conditions and executions. The conditions hook into events, kind of like the latent actions, and we'll constantly monitor when something changes on them. Once that's fulfilled, it will then try and execute the actions. So the events, again, they dynamically bind, and they're built from objects instances, which means that we can very easily kind of build out, kind of like the expressions, custom conditions that actually also use expressions. So you can do ands with these as well, and ors and whatnot, and kind of build out all the conditions you want for when you want to fire it, which for a narrative-based game is very helpful. A lot of times, like this image, we would have narrative windows where we only want something to happen within that period, and if you're haven't done that narrative event yet, we don't want to trigger it early. It also means we can then trigger our executions based on this. So once we've, within a narrative window, done the action we were waiting for, we can then fire off the event to progress the narrative, and then do, let's say in this example, a sequence that then plays based on that narrative. We also had a trigger once option on these events, which means that by default, once they execute, that's it. But if you have it off, it means that it can be refireable. So you can basically trigger on and off, so less relevant for narrative, but for more gameplay stuff, such as a trigger volume with a door. Obviously, when you go in and out, you want to continuously re-trigger. And again, some audio could happen based on that, some visuals, that kind of thing. Based on this kind of flow of the fact that it can be on and off, you can have kind of the stuff on blueprints. And what that means is you can actually query, based on context, the blueprint itself. So it means that you can check the tag state on this current actor, and then apply tag changes on this actor, also using gameplay effects. This is driven by a component. So we have a component that manages all these modular events. And then there's also a callback event that you can bind into if you want to do custom logic on top of this for when that execution has run. So you can kind of just also use this without any executions and use it as a bunch of conditions that you want to just quickly build out some rule set and then trigger with when that happens. It kind of means you don't have to have all this custom stuff in a blueprint for a bunch of bindings, checking all the states, and then you have to change it if the conditions change for the design. So it's quite modular in that way. And again, it's very beneficial with on blueprints because it means that each blueprint that spawns has its own self-contained logic based on tags, based on it can again involve narrative, outside conditions, can even point to stuff in the world like a NPC or the player, and then based on those conditions do a certain action. As I mentioned, referencing a actor, You have the cross-level actors problem, where if you reference something that isn't in the same level, it means that obviously it could not exist, especially with our game where we kind of have progressive level loading. So you would load a level as you get through a certain area and unload the previous. It means that one actor cannot assume the other actor exists yet. So when it wants to usually bind its events, you have this issue where it doesn't exist yet. So it needs to wait until that does exist. So what we essentially do for this is we use soft pointers as the actors, so that it doesn't require them to be live. And then we can kind of hook into those bindings. And the way we do that is with a registry. So we made our own actor registry, which essentially, when we want to listen to a certain event, we ask the registry to tell us, based on the actor pointer, the soft pointer, when it exists. That soft pointer is treated as an ID. That has to be the original package path of the ID. It obviously can't be the live ID, because when it switches levels, that will then change, and ID you're using to listen to will no longer match. So it's the original ID, which we also use for our save IDs, for our save system. But yeah, so once you've got this binding, then when the actor hits its begin play, it exists. It can then tell the registry, hey, I exist. What that means, it sends out, broadcasts to all the other objects listening. Then, as per usual, they can do their bindings. And again, what this means is the same way we could do that kind of dynamic binding with conditions. It means even with actors level, we don't have to do this manual checking of, hey, when does an actor exist, and then check the conditions again. It's kind of just all there based on just that drop down. You can just pick the actor, pick the conditions, very quick, kind of build out these levels. Yeah, and then some quick debugging tips. So there's this command, which is very helpful for just showing in world the current tag count or tags that exist. This tag, once you turn it on the editor, will stay on. You don't have to turn it on each play. It will show the count, but it does require a active component being rendered for it to show up. It's kind of how it works by default. There's also the visual logger. So the visual logger is actually like a timeline of the things that have happened, but it doesn't do standard tag changes. It will only be if it's a gameplay effect or ability. So if you're using gameplay effects for most of your tag control, it will show up here, which is very helpful. If you are doing manual tags, you can extend and add custom stuff to the visual logger. So if you kind of have your own system for when you apply those tags, you could add this as another layer to it. But yeah, the benefit of this is you can kind of very easily debug what happened if you want to know why something went wrong. And it also has the visual in world to show you where the thing is that you're currently looking at. So I did plan to do a bit more of talk around a new system I was building based on this. I actually didn't get the time. I did actually run quite quickly, so maybe I'll just quickly talk over it. But essentially, it's this gameplay flow system, which kind of takes the same concepts with the conditions and executions, but what it uses there's a flow plugin that's just on GitHub for free. And essentially, it kind of extends that to have more of a flow as opposed to just what we call drop-down hell, because it kind of got quite chaotic with these events. You're just getting these layers of drop-downs, and our designers did not like using it for that purpose, even though it was very powerful. And as per like a narrative application, they prefer graph views and kind of more like blueprint direction. Essentially, this kind of gives a bit more of that visual, of that control, but without the full complexity of like blueprints with the variable input nodes. So it's on purpose that you can't do input nodes on this because it's not supposed to be full blueprinting. It's kind of this main flow. But essentially what I've done is I've extended the existing plugin to kind of have this gameplay abilities layer. What this means is these same events you had, such as listening for a gameplay event or listening for tag changes, you can kind of build those out. You can see that on, say, can I see it? The middle condition is kind of 3 tag checks. So there's 3 different kind of tag checks, and you can see on the left, that's a gameplay event example, but you can essentially customize each of those little blue sections as a different condition. You can see how this is better than the blueprint, the drop-down hell, because each one you can just have a single field based on what you're clicking on. You don't have this big list based on all the properties. And then it means that you can then, again, have the conditions here, but you can see based on the conditions and other conditions what events you want to fire, and you can have that loop around and kind of a bit more control over that looping behavior. And it kind of just gives a bit more control. But this is just something I was kind of still working on that I haven't kind of fleshed out yet. So I have resources, as I mentioned. I just quickly made a GitHub page with just simple markdown, but it does have the link to the slide, but also the ability system. That is very much work in progress. I'm kind of just working on it. But if you need any things that you want from it, you want something exposed, then you can just ask and I probably can do it because it's quite basic. And again, surprised there's not many of these plugins out there. And then as I mentioned, that gameplay flow plugin, I definitely want to work on it more and then kind of make it exposed so people can actually use it, make it public. And I probably will add to this page just some more resources, maybe some generic gameplay ability resources as well. Yeah, so that was faster than I expected, but any questions? Oh, it's clap first, yes. Yeah, any questions? Yeah. Just wait for the mic, sorry.
Hi, that was a really informative talk. Thank you. I was wondering if the gameplay ability system is isolated directly to just actors, or can you use it in other components of Unreal, like the UMG system or something like that?
Yeah, I mean, it's kind of a generic system, so you could definitely query stuff from UI and such, but it's you probably wouldn't use it directly. But it's kind of just a generic system that you can just use however you like, as you saw. The focus they built it on was for abilities, but as I showed, you can kind of extend it just for more generic systems. Does that answer the question?
Yeah.
Given the way you're using gameplay tags to, I guess, manage the state of objects, like, does that help with, say, debugging things real time or like save management and recovery?
Yeah, so you can essentially, as I mentioned, I have commands to add tags in the same way we had a command to kind of debug those tags. So what it means is if you have a bunch of these kind of actors and levels, such as levers, such as doors, you can, using either that command I showed or a custom one we had for VR, query those tags while you're in a build, such as a test build, and say QA is going through stuff and you're like, why did it break? Why is the thing not opening? It's very easy to use that debug command, show the tags, and it means that you can go, oh, it's not got the tag. Okay, so something went wrong with that stage. Why did it not have the tag? And then because you have the commands that we exposed to modify those, you can add the tag and check if it progresses, or vice versa, remove a tag, trigger events on things. So it does mean that if you weren't using the gameplay ability system, obviously you can't just easily query any actor like that with commands, because you'd have to manually expose it through each actor or have some interface that kind of does that information and presents it in some form, and then you modify it in some form. So using the ability system, it just means it's just a generic existing platform that you can just query that and set that, and it's just generic for the whole game and all the context you use it for. Yeah. Cool. Thank you very much.